we want to look at the most important topic in pure mathematics that is found in the branch of calculus. So we want to look at differentiation. That's our topic, is differentiation. So let's look what is differentiation. So differentiation is the process of finding the gradient function of any given function at any point. That's it. And also the derivative of a function is also known as what? It can be called gradient function, second derivative, third derived function, fourth differential coefficient. Thus other names that are given to derivative of a function. So normally we have the notation that we use when we differentiate a function, any function. So we are simply saying the derivative of a function y with respect to x, normally written as WRTS, and normally written as dy dx, or that y or y prime. So that's all about the notation of differentiation. Fine, let's look at the cases of different types of function. But in this video, I want to look at how do we differentiate polynomials. That is the case number one, that is differentiation of polynomials, like it is written there. So under differentiation of polynomials, we have different aspect that one is ought to know. The first one, we have the derivative of a constant, let's say constant a. So a prime, that is differentiation of a, is equals to 0. So we are simply saying every time when you differentiate a constant, the result is always 0. A constant, by the way, is a non x0 a digit. So that's all about the derivative of a constant. Example, y is equals to 5. If we differentiate y with respect of x, we don't have x there, so which means 5 is a constant. So dy dx is 0, like as it is written there. So let's look at the part B of differentiation of a polynomials. We have derivative of any power of x, that is x to the power n close bracket to the power prime. It simply says differentiation of x to the power n. So here we use the symbol row. The symbol row is times and take. It's times and take. We take x, we take power n and bring it down, and also we take minus 1. So we bring down x and also we separate n. So yeah, there we get nx to the power n minus 1. So that's it. So it's times and take. So that's the whole concept of differentiation is separate. So fine, let's look at examples. The first example there, it's y is equals to x squared. So in order for us to find dy dx is equals to, like we said, we bring down 2, so it becomes 2x to the power 2 minus 1, because we said we separate 1. So 2 minus 1 is 1, so our answer there is 2x. Fine. So that's all about the first example. The second one is say y is equals to x to the power 4 plus x to the power 3. So now in order for us to find dy dx, we're supposed to differentiate term by term there. So if we differentiate x to the power 4, we bring down 4, and also we separate minus 1 to the power. And also we want to differentiate x to the power 3, so we bring down 3 and we separate the power. So our final answer, it becomes 4x to the power 3 plus 3x squared. So that's our answer. So that's it on derivative of any power of x. So fine, let's look at another aspect there. It's a constant multiplying the function f of x to the power prime, which means we want to differentiate a situation whereby you have a constant multiplying the function. So the thing there is we take the constant and then we differentiate f of x. So it's constant multiplied by f of x. We don't differentiate constant there. So fine. Let's look at examples. The first example there is y is equals to 2x to the power 5. We see that 2 is a constant there. So bring down 5, and also 5 is going to multiply our constant 2 there, and also take minus 1 there at the power. So 5 by 2 we get 10x to the power 4. That's the first example. And also the second one is saying y is equal to half x to the power 4. So in order for us to get dy dx, we are going to bring down a 4, and also it become half by 4, and then x to the power 4 minus 1. Likewise, we take minus 1 at the power there, and also we get half of 4 is 2x to the power 3. So that's our answer there. So now we want to look at the last concept in the derivative of differentiate our function ax plus b to the power n. We want to differentiate that kind of a function. What are we doing there? The thing will bring down n, and also in place of s, we differentiate the function with x there inside our bracket. So if we differentiate ax, we find our answer is a. So a is going to multiply with n, and also likewise we take 1 at the top. So it becomes a n open bracket ax plus b to the power n minus 1. So that's how we differentiate that kind of a polynomial function. Fine, let's look at examples. The first one is y is equals to 7x plus 1 to the power 5, and also so dy dx is likewise we bring down 5, and also we find the derivative of 7x. So we get 7 open bracket 7x plus 1 to the power 5 minus 1. So 7 times 5 is 35 open bracket 7x plus 1 to the power 4. So that's our answer there. And also the last one is y is equals to 4 open bracket is 4 over open bracket 2x plus 1 to the power 3. So we want to rewrite that function, remember, using the laws of indices, that is the law number 4, which deals with the negative powers. So we simply say y is equals to take that 2x plus 1 to the power 3 at the top, so it to become 4 open bracket 2x plus 1 to the power minus 3. So now we want to find dy dx there. Likewise, we said we differentiate the function in x inside the brackets. If we differentiate 2x, we find our answer 2, and also bring down minus 3, and also we multiply with the constant using the fact that we used in part C. So 4 times 2 times minus 3, we get minus 24 open bracket 2x plus 1 to the power minus 4. So our final answer is equals to minus 24 over 2x plus 1. I just bring down 2x plus 1 to the power minus 4 to make it a positive value. So that's it when we differentiate the polynomials. That's the cases that one ought to know very well going forward. And also there I've practiced questions. So normally practice those, and remember they say practice makes one perfect. So guys, thank you for watching the video. So now look out for my next video, that is case number 2, differentiation of trig functions, that is trigonometric functions. That's the next video.